Hello, everyone. Welcome to today's webinar, Tecnomatix Plant Simulation. I'm going to go ahead and get started with this now. It's a couple minutes after 2. We've got our stragglers in, so I'll get this started now. Welcome to today's webinar on Tecnomatix Plant Simulation, and we'll talk about advanced optimization, and we'll look at using workers in this presentation. So hello everyone, my name is Glenn Borgesen. I'm an application engineer at Geometric Solutions, and I've been in manufacturing, product development, product lifecycle management for my entire career. And I want to show you plant simulation and how it can help you with your manufacturing processes. So what we'll do is we'll look at today's agenda and go from there. So what we'll do is we'll talk about plant simulation briefly and what it is, how it can help you. And then we'll get into some simulation demonstrations. So we'll be referring to Tecnomatix plant simulation as just plant simulation from here on out. That Tecnomatix is the bundle of those tools. So we'll get on with this. Before we get deeper into it though, if you have any questions, you can go ahead and type those in or contact us afterwards. There won't be any handouts, but if there were, you would see that in the drag and drop file. So Geometric Solutions is a company I work for, and we sell the best-in-class software, which is Siemens Software Solutions. Now, I'm part of the Weltonen family of companies, and at Weltonen Engineering, we house hundreds of engineers and designers that can design anything, and they use the Siemens tools that we're going to be talking about today. And so they use those tools, they design whatever they need to design, and we can send it right over to our tooling supply shop, Independence Tooling Solutions, and they can build it. And so we've got a real turnkey production here, so we can design and build the tools that you're going to use in your manufacturing process. We can do that all using the Siemens software. Now, our owner, Lloyd Brown, put it really nicely. He said, our ability to successfully partner with our customers comes from our experience in using the tools we sell every day. So we are using these tools, and we are putting them to use, and we also sell them, and we sell services. So we're putting our money where our mouth is. Now, let's look at plant simulation briefly and see what it is and how it can help you. Now, in today's world, we have a lot of issues that are coming up and increasing our risk. A lot of them are increased quality, lower cost on the industry side. They want compressed timelines, faster, quicker. And then on the manufacturing side, you've got cost overruns, launch delays, validation processes that are really huge influences in your business. And so plant simulation can help you manage this. And this is going to be the way that you can manage your risk. And this is using the digital twin of plant simulation. So you can figure out your problems using a virtual world, and then you can get into the physical plant. So when you get to the plant, you're not running into a launch delay or cost overruns, or you're trying to validate the last minute in the plant. It never works out well. I think we've all been there, so we can do it virtually now. Now, what are the benefits using plant simulation? Well, there's a lot of them. So it'll improve and optimize the production of existing facilities. It can reduce planning of new facilities. So you can plan your new facility without getting into any physical parts. So it's right away. Reducing inventory and throughput time. Now, if you talk to a plant person, say, hey, we're going to reduce your inventory in the plant because of our system, they're going to be pretty happy with you. And then you're going to increase throughput. Well, it's hard to believe. So these are some great benefits here. It'll let you optimize system dimensions, including buffer sizes. We'll look at that today too. You can lower your risk. through early proof of concept. So that's a way to mitigate risk and remove that from your work. It'll let you maximize your manufacturing resources, and you can prove that all out in plant simulation. We'll look at that too. It'll detect and eliminate problems digitally instead of physically. Again, when you're cutting steel and you find the mistake, it's way, way too late. It's going to be expensive. So let's look at some optimization methods. And in a previous webinar, we had come up with a scenario where we had 3 stations with a specific throughput. We have a buffer capacity. Our station times are 36 seconds. This is kind of a scenario we started with, and it's a typical scenario that we've dealt with customers before. So we look at this and we want to optimize our throughput using experiments. And the experiments indicated a buffer size of 16 in this case would better suit our needs. So this increased our throughput to 77.4 from 75.3. So it went up a couple. That's a big deal for 1 hour. And then you think about a day and then a week and a year, it adds up. Now, manufacturing process had to be added. This is after we developed our system. So it increased the cycle time of that station to 54 seconds. So we had to maintain our current rate of production or improve it. Well, it's a number of things we can do, but we got together and put our heads together, and what we did was we added an extra station to make up for the operation. And using the experiment manager, we increased buffer capacities to 16. I'll explain to you what that means when we get into the model. And we increased our throughput to 78.2. So we're able to increase the throughput a little bit, not much, but we kept it up to what we wanted. And then we've now been tasked, after we've done all this, we've been tasked to increase our throughput to over 95 an hour because of market demands. Well, it's a problem that we need to solve, but it's a good problem. These are the problems that you want to have. Increased production, we're selling a lot of these. So what I want to do is talk to you about how we did that. So some of the restrictions, our station times cannot be increased. That process is what it is. And we are now authorized to use robots if they are needed. So what we'll do is we'll take a bit of time and we'll start looking at this process simulate model that I created. So in another webinar, we had the first 3 station lines, station 1, 2, and 3, and in between them we had buffers. I developed an experiment, and I won't get into all the details of it, but I'll show you the definition of our experiments. We're trying to determine the capacity of these buffers to increase our throughput, to maximize it. And so I set up an experiment to change the buffer capacities in the 2 buffers that we're using. And what the experiment manager will do, it'll run through all of these experiments, and we're going to do 2 observations per experiment. So 15 different experiments, and we're going to run through them twice. And the experiment manager will put the best quantity in the buffer, and I'll show you how that works. Again, this is a bit of a review, but I'll go through this fairly quickly for you. So I'm going to run my experiment, and it's going through all these different observations right now, and it does it in just a few seconds. So a little over 5 seconds, and I've got my simulation results. Well, I can take a look at them. It comes up in this nice report. But I want to go to this chart here for just a minute. These are the different experiments, and then the throughput is listed here. Well, you know, sometimes reading a chart is a little difficult. The best thing about this is it displays it in a graph so that I can see right away this curve here, and I know when I'm getting to the flat spot, I'm really optimizing my production. And so right in the middle here, I can see my buffer capacity from 14 to say, oh, maybe 20. is kind of hitting that sweet spot where I'm getting a really good return on my dollar for my extra capacity in my buffers. So what I want to do is go back to my model, and I'm going to use 16 as my buffer size, and we'll look at my throughput. So I'll come back to the model, and very quickly I can change. You'll notice too, by the way, the capacity is at 30, and that was part of the experiment. If you don't mind all these charts coming up, but in the experiment manager, it took the highest value that gave me the best production. But then I determined, looking at the graph, 16 might be just sufficient. I'm not really getting that much more production going to 30. So not to get into too much detail, but it's just something that plant simulation can do for you that's really straightforward. So I'm changing the capacities on my buffers now to what was recommended in the experiment. And now I'm going to run throughput or run my simulation. And look at that. I got up to 76.91. So I've improved my production using the experiment manager. Now, remember we had to add an operation to that last station. So what we did was we split the models and added another station to provide us for the time. So the original stations were at 36 seconds. And now we had to increase the cycle time, the processing time in the last station because we added that operation. We can't get around it. But the original station times are the same in the first two stations. The buffer size is at 16. That's from the previous model. So we'll leave that there. And then I'll show you what I did in the experiment manager. So I built the experiments again. This time I'm going from 1 in some increments up to about 100, just to see where I'm at to increase my efficiency, to maximize my production. So what I'll do is I'm going to run this experiment manager, so it'll determine the best outcome for my buffer capacity. 3.5 seconds, not much time to wait for that. I'll scroll down to the chart. That's what shows us the optimum. So I can see between, like, say maybe 10 and 20, I'll hit my sweet spot. So I don't need to necessarily go to a capacity of 100. 20 might be good enough. And the difference between those two might be that the cost is not advantageous. So I'll go to 20. Again, changing my buffer capacity. And again, it's at 100 because that's what the experiment manager said was optimum according to my experiments. But 20 is very, very good. So then I'll run my production again, or my simulation, and I'm at 78. So we've got increased production here with this setup. Now, if you remember, excuse me, the product was selling like crazy, so we had to increase production. And what we did was we added a robot to the new station. So I'll show you the evolution of this in just a second. And then, sorry about that, we added 2 parallel stations. So instead of doubling these stations, we just combined them together and kept the footprint relatively the same in the plant. And this robot didn't take up much more space. But if you look at the evolution of this line, it went from our first 3 stations here. Then we had to split the stations and add 2 more stations. And then we needed to increase our production. So we added a robot right here. And then we added 2 parallel stations. So let's take a look at this, this model here. Now, I want to look at the buffer, and that should be 20 from what it was in the previous experiment. And if you look at my experiment definitions, I've got a similar kind of ramp up on the capacity here. So I want to find out what's optimum. I'll run my production, or my experiment manager. In 7.8 seconds, I ran an experiment, and I'll go right to the graph. And you'll see that at a buffer capacity of 4 or 8, I'm kind of optimal. So if you look at, once I'm at 8, my throughput really never changes too much. So I'm going to go with 8 on my buffer capacity. And we're at 98 right now, but my buffer capacity was at 100. So I'm going to take it down to 8. And with 100, I had about 98 parts per hour on my throughput. So I'll run my production again, and I get to about 97.5. So I'm above the 95 that was asked for by management, and I didn't increase my footprint size that much. So I think we've done a great job with getting the production to where it's at. So let's look at this. So we added a robot to unload station 3 and 4, and then it goes to the shipping station. And we use 2 parallel stations to increase our production. Production's now at 97.5 per hour, and we didn't change the footprint of the plant. It stayed the same. So it's a big win for us. And this is something that you can do with plant simulation, and it's virtual. We haven't built anything yet. So we can prove this all out without having to build a physical model. Now moving on, we'll look at plant simulation, adding workers and variants. So here's our scenario. We've got a 7-station line, we have a worker pool, and we have some variations to build in this particular production plant. So these days, you see help wanted signs everywhere, right? It's a wonderful problem to have when you're looking for work. But sometimes, just because there's a help wanted sign doesn't mean that you know how many workers you need. Well, with plant simulation, I can find that out really easily. So I can run some simulations and find out a way to get the most out of my investment in my plant. So how many workers will give me the most economic production? This is what we're looking at today. So in this example, we have a 7-workstation cell. The last station, 7, it uses as a delivery station to shipping. So the workers are working in this area, and they're going to go from station to station and produce these parts. But we have a twist to this. So we have 4 variants to make for this work cell. All the station times are 30 seconds. We can't change that. And we can use as many workers as needed. Well, let's find out how many we need. So in this production line, we're going to build 4 variations of a part using different combinations of stations. Well, how do we do that? Well, for part 1, we'll go station 1, station 2, and then station 7. That's what's going to build this first variant, which is part 1. So we always start at the source. We take our product to station 1, 2, and drop it off at station 7, and we continue that cycle for part 1. Now, part 2 goes to station 1, then to station 3, then to station 7. That produces our second variant. Now, we want to build our part 3, which is our third variant. That goes to 3, to 5, to 7. Now, again, they're all returning back to the source to pick up some more product to make. And then our final variant, part 4, goes from station 4, 5, to 7, or 4 to 6 to 7. So Under most circumstances, this would be fairly complex to figure out how many workers would make this most efficient. Well, using plant simulation, we can get a lot of answers without having to find out the hard way. So what we do is we use a production schedule and we build that into the plant. And so what this will do is let us build these variants, and I'll show you how that's done. And it's a really cool tool. So we're going to use data tables, and it'll let us create the complex manufacturing processes. And the way this works is I build a table. I've got my 4 parts, part 1, 2, 3, and 4. And I build a table of attributes with these parts. And what's cool about this is that for every attribute, I can build a table that will tell me where the worker has to go. So he starts at the source, goes to first workplace, second, third, and fourth. Remember going from 1 to 2 to 7? That's all been laid out in the production schedule. So let's take a look at how this works. I have a model for you, and we'll take a look at that. Let me open this up. So here's our model with our 7 stations, our production schedule, and we have a worker pool. Now, what I'd like to do is take this out of the plan view so we can watch our workers busy at work. And right now in the worker pool, I have 1 worker allotted to this. So let's see how this works. I'm going to run a simulation. I'm going to slow it down so we can watch our workers working. It's kind of cool. So I'll start my simulation. And here comes my worker. It's a little early in the morning. He's kind of slow. I'm going to give him a cup of coffee here. Here we go. So I can watch him work, and he's going to go through his process and do all the operations that I've described for him. We'll watch him for a little bit. And then I'll just go ahead and speed this up all the way and finish my production cycle. And I'll notice that with 1 worker, I get 6.7 parts per hour. Well, that's good. So let's figure this out. I'll go back into my worker pool and I'll grab another worker. I'll have 2 workers this time. I'll reset my simulation and then restart it. I'll slow it down so we can see both the workers busy at work. It's easier to watch somebody than to do it yourself, right? So here comes my workers. They're coming out. They're going to start building parts. Speed up a little bit more. Everybody's having coffee today. So they're all busy in their work cell. And right now I have them going from point to point. There's no work paths or any obstacles in this. You can build those in if you need to. But we're watching the workers get about and do their business. I'll speed it up all the way. And with 2 workers, we find out our throughput is now 13.3. Well, we're going the right direction. Started at 6.7 with 1 worker, 13.3 with the second worker. Let's see what adding another worker will get us. Now, if you're thinking, why didn't I run experiments with this? You can't run experiments with the workers. Just a subtle nuance, but I'll reset this and our 3 workers will come out. Let's watch these guys work a little bit. And here they come. They're all coming out to work, all 3 of them. And I'll speed this up all the way to the end. 18 parts per hour. Well, we're getting somewhere now. So 3 workers, I get 18. 2 workers, 13. 1 worker, I get about 6. Let's see what 4 gets me. Maybe I'll get more. Maybe. And I'm going to leave this production at full speed here. And I'm at 20. So I went from 3 workers at 18. 4 workers, I get 20. Let's go ahead and try 5. And I'll leave this at max speed. So I get in 21.43 parts. So what I found is that with one worker, we get 6.7 parts. With two, I get 13.3. Then with three, I get 18. And then as I add another worker, the increase in production drops off. So I increase 2 parts per hour with 4 workers, 1.5 parts or so with 5 workers. So I think 3 might be the best solution for us. I'll go back to this worker pool, make my worker amount 3. I'm going to reset this and run production again. And I've got 18 parts per hour. And I can look at my worker chart here. And let's talk about this. So right now, my 3 workers, when you look at this light green here is when they're working. And then I've got this green that's carrying the part. I can't really get around that right now. I've got some walking involved, and then I've got some waiting with this gray. Now, the worker's efficiency isn't the greatest, but we can deal with that in another lesson. And then if I look at the station utilization, you'll notice that my 7 stations are fairly underutilized. The green is working, the gray is blocked or waiting, and the yellow is blocked. I don't like this. I would like to increase my efficiency, but what to do about that will be another story at another time. So we've taken these workers and built all our variants, and we got our production to 18 an hour with 3 workers. So let's look at the results here. So we modified the workers. We used the production schedule for our 4 variants, and we found that our worker throughput started to increase relatively well until we got to 4 workers, and then it kind of fell off. So we decided that the optimum would be 3 workers. Our throughput will be 18 jobs per hour. And that's a way that you can look at your throughput, add your workers, and get the most out of your current situation. So I'd like to thank you for attending today. If there's any questions, go ahead and email them at solutions@goplm.net or scan this QR code, and we'll get back with you right away. So I'd like to thank you for your attendance today. Thank you, and have a great week.